Okay. So you should have warm-ups for Unit 4 as well. We're gonna look at, so if you haven't watched the video yet, you might be a little bit lost. That would be a great thing to do over academic support, is watch the video, part 1 for this. So we started last week talking about triangle angle sums and how to solve problems using the sum of the angles in a triangle. So how many angles are there in a triangle? Or what's the total degree measurement within a triangle? 180. So I can solve for x by knowing that this triangle has to total 180. So I can either set up like one whole long equation. So one option is to go, well, 5x plus 5 plus 70 plus 75 equals 180. So just so you know, yeah, so I gave you, you have the notes. It's a separate packet. I gave you all the warm-ups and checkouts in a separate packet. Sorry, I kind of set you up to fail there. So you have all 3 packets. So look in your binder to find the one. This is the very first page on the warm-ups packet. So WU triangle angle sum. Might have a couple left if you need it. Anyone need another one of these?
Yeah.
Need one? Yeah.
I mean,
You have them. Just
I
not
have
here.
them, I just don't have them.
Okay. So that's one option. Another option, I think a little bit easier because I'm going to end up with smaller numbers initially, is I could combine these and say, well, okay, on this problem, so that's 145 degrees between those 2 angles. So then how many degrees must this angle be if it's going to add up to 180? So I have 145 here. This must be 35. Yeah, just I think it just is a cleaner equation. So I could just go ahead and find that angle and then say, okay, well, 5x plus 5 must equal 35, which I would have gotten here eventually anyway. And it's not always possible to do this. Like I could have x in all of my angles, in which case I'd have to write this strip out of all 3 angles add up to 180. But here I kind of have some choices. So then I subtract 5 and I get 5x equals 30 and divide by 5 and I get x equals 6. Okay, Stella, we're doing the warm up, the first warm up in the packet. So same idea on the second one. I know 2 of the angles, so this is a 90-degree angle. And this is a 60-degree angle. So altogether I have 150 degrees, which means that this angle must be how many degrees? 30 degrees for the triangle to add up to 180, or x plus 37 must equal 30 degrees. And subtracting 37, x equals -7. Okay, so with our triangles, just using that idea that we know the whole triangle has to add up to 180, and either filling in what my missing angle is or taking all 3 angles and setting them equal to 180. On 3, it gets a little trickier. So it uses some angle relationships we know about from past units. So one angle relationship it's using is here. What type of angles would 92 be in this angle at the top of my triangle? What is this angle relationship called? Vertical angles, yeah. So it's giving us vertical angles here. And I know that vertical angles are congruent. So I'm going to use that to fill in that this angle must also be 92. Okay, that these are the same angle measurement. So it's using that relationship. These are vertical angles, which are congruent. And you'll see some of these in the homework as well. And then it's also using linear pairs. So down in the bottom, this is creating a line. So if this is 149, then what this angle has to add up to 180 with that. Anytime I have a line, it adds up to 180. So that means that this angle would be what? Not quite, more. 31, yeah. And now, so now I know this angle and this angle, I can find this angle. Okay, and it's gonna get even trickier over here. So I can go, okay, well, 92 and 31, that gives me 123 between these two angles. To find this angle here, I can do 180 subtract 123, which gives me 57 degrees. Okay, so vertical, linear pair, triangle equals 180, boom. Now again, I have a linear pair, and that's how I get over here to x. So I go, okay, well, if this is 57, well, flip this around. If I do 180 subtract 57, that's going to give me that this angle is 123. Okay, or notice, because this is going to link to our notes today, this angle is the same as the sum of these two angles. Why is that? Because this angle is creating a line, has to add up to 180 with this angle. And these angles have to add up to 180 with this angle because they're inside a triangle. So notice they do kind of have a special relationship. We talk about that today. Okay, so using this line, I know that that's 123. So x plus 130 equals 123. Subtracting 130, x equals -7. Okay, same kind of game we're going to play on 4. So on 4, it gives us some linear pairs. So if I know that this angle is 55 degrees, what must this angle be? Or not 55, 155 degrees. This angle must be 25, yeah. And up here, if this angle is 45, then this angle creating a line with it would be how many degrees? Let's add up to 180, so 135 degrees. And then again, I have two choices now, so I can make a like 25 plus 135 plus 2x plus 2 equals 180. Or I can say, okay, well, 25 and 135 together, add those up, is going to give me 160. This angle has to be 180 degrees, subtract 160, or this angle here must be 20 degrees because I know that the triangle altogether has to add up to 180. Okay, so kind of two ways to figure out an equation to set up to solve for x. So I know that 2x plus 2 must equal 20, or 2x equals 18. And that's how I get to x equals 9. Okay, and we had some of this in our homework as well. And so on Friday, I posted the video. That was the first set of notes. And you didn't have to submit this homework yet. It's not due until tomorrow at whatever, 8 a.m., whatever it sets to. Okay, but I did ask you to look at the evens just to kind of pace you so you didn't have to do the whole thing. If you haven't done the evens yet, again, now we've started this, you could go through and do all of them. So I want to go through the evens in this homework first. So you could, if you haven't done it yet, take notes with me. Or if you have done it, you can kind of check your work as we go. So we're going to go down through the evens of homework number 19, take some new notes, and then you'll be able to complete them. Some of the odds you wouldn't have been able to do without the new set of notes from today. Okay. Homeworks. Does anyone need a new homework? Homework packet? Copy more of these. Anyone? Homeworks, we have them. Okay, homework number 19. You don't have it, you could also use a blank piece of paper. So 2 is really similar here. I have 90 and 30, so that's 120 degrees, which means this angle must be 60 degrees. And so I set up my equation, and we get x equals -9. Okay, I know that that angle x plus 69 equals 60. Solving for x gives me -9, using the fact that the triangle equals 180. 4 gets a little more difficult, so it uses those angle relationships. This is a vertical angle, so this is 30 degrees. This is a linear pair, so this 100 plus 80 would give me 180. This has to add up to 180. These are congruent. If I have 30 and 80, then altogether I have 110 degrees so far in that triangle. which means that my remaining degree here should be 70 degrees. And then these are vertical, so this angle is also 70 degrees, or x plus 73 equals 70 degrees, and x equals -3. Okay, so linear pairs, vertical angles, and find our x value. 6 looks almost identical to 2. I have 30 degrees and 90 degrees, so that's 120 degrees altogether. That's a 60-degree angle. So setting x plus 72 equal to 60, you get x equals -12. Okay. When you got to 8, it got a little bit more challenging. So you have to do more than just solve for x. So 8's on the back side. I don't know why I did that. I didn't go 2 columns there. Okay, 8's a little bit challenging in general too. I mean, so I have 2 options. I can set up like a string, all 3 angles equal to 180. Or I could say, okay, I can take the 80 degrees out. And I know that these 2 angles combined have to add up to 100 to make the triangle add up to 180. However you did it. I'll start by putting them all together. So x plus 61, this angle, plus the other angle, which is identical, plus 80 degrees, the third angle has to add up to 180. That's one way you could have set it up. Or again, like I said, so I'm going to combine these as I go. I have 2 x's and 122, subtracting 80. Okay, that between these 2 angles is 100 degrees. Okay, another way you could have done it, or I could have added 80 in there too. Just kind of saying there's 2 ways to look at it. The whole thing equals 180, or these angles have to add up to 100 for that to work. Subtracting 122 gives me -22, and dividing by 2 gives me -11. Now I'm not done here. The directions on 7 and 8, and I think down below too, well, down below is a little different. It says find the measure of angle A. So that's why this one's marked A. Okay. So now I know x equals -11. The measure of angle A would equal -11 plus 61. Or angle A must be 50 degrees. Okay. So there was an additional step on 7 and 8. Where first you got to figure out what x is. And then once you know what x is, you have to write what your angle is. Which you could have maybe figured out anyway, because these are the same. So if it has to add up to 100 and they're the same, they have to be 50 and 50, however you got there, okay? Okay, then these are like little puzzle problems. So it wants this angle here. Again, my triangle totals 180. So here I have this triangle where I know 2 out of 3 angles. Here I don't know, so I know that this angle is 90, but I don't know like how much of 90 is here and how much of 90 is here. So I can't like use that to find this angle. I have to first go, okay, well, 71 and 71, that's going to give me 142. So then this angle would be 180, subtract 142, or 38 degrees. The reason that it's marked 90 is so that I know if this little bit is 38, then this remaining angle here has to be from the 90 degrees. If I subtract 38, how many degrees is this angle here going to be? If this is 38 and the whole thing's 90, this has to be 52 degrees. Now, why do I need that? Well, now I have 2 angles in this triangle. So 31 and 52 gives me 83 degrees between these 2. And I can find my missing angle by subtracting 83 degrees from the total triangle that has to add up to 180. Am I doing an odd? I'm doing an odd. Nobody stopped me. It's okay. I'll leave 10. We'll go over 10 next time. That's going to give me what, 97 degrees. Okay, so it's kind of like you got to piece together what they give you. We know things about right angles. They add up to 90. That little box in the corner. Triangle adds up to 180. 10 is the same idea. Okay, I won't go over it right now just to save us some time, but triangle totals 180. Vertical angles, triangle totals 180. We also talked about classifying triangles, so, okay, just evens. So we talked about they can be equilateral, isosceles, or scalene. Equilateral, all sides are the same. That's what we have here. Isosceles, 2 sides are the same, or scalene, all 3 sides are different. And then we talked about acute, obtuse, or right. So acute, all of our angles are less than 90. Obtuse, 1 angle is greater than 90, just like an obtuse angle. And a right triangle has a 90-degree angle. So this is an equilateral, meaning all sides are the same. Now really it's equal angular, but you could have also put acute. Okay, but notice all of my angles are the same, so same as equilateral, we can say equal angular, so you'll see that wording as well. In terms of the words we had in our notes, those are all acute angles, so equilateral, acute triangle. On 14, all 3 sides are different. So in our notes, we have that as scalene. It's a scalene triangle, all 3 sides are different. All of my angles are less than 90, so actually I would normally write it this way. Acute scalene. Okay, it's an acute triangle, all of the angles are less than 90, and all 3 sides are different. Okay, and so for homework tonight, you're gonna look at the odds on number, what is it, number 19? Okay, so you can tuck that away for right now. We only have 15 minutes, so I'm gonna move right along here. So we're just gonna add to some of our properties of triangles, and some of these things we're already gonna know is true, but we're just gonna kind of point out that they're true. So I'm on page 4. It's day 2 of notes number 1. First one we should already know, first bullet. The sum of the angles in a triangle is 180. Yeah. So that's just a reminder. We're going to use that over and over and over again, probably really realistically all year long. An equal angular triangle, so we just use that in our homework, is when all of the angles are the same or equal. What must that mean is true? If all of the angles are the same, so let's put the 2 pieces together. All the angles are the same, a triangle has to add up to 180. If it's equal angular, if all of my angles are the same, then each angle must be how many degrees? If it's all broken
60.
down evenly, it has to be 60 degrees. Okay, we would have been able to work through that anyway, but that's a property that's good to know. Each angle must be 60 degrees. If a triangle equals 180, if I divide that by 3, that gives me 60 degrees each. Okay. In a triangle, there can only be one right angle or obtuse angle. Okay, so if I have a right angle, I can't have another right angle. Okay, that would be the beginning of like a square or a rectangle. Plus a right angle plus a right angle is 180 degrees out of 2 angles. So that's not going to leave me any room for a third angle in my triangle. Okay, so I can only have one right angle, and these angles here must be acute angles. Okay, they can't be obtuse angles either. They have to be angles that are less than 90 in order for all 3 to be able to add up to 180. Same idea with a obtuse angle. The acute angles in a right triangle, so let me redraw my right triangle. We said here's our right triangle and here are our acute angles, same diagram as above. So I have X and Y. I'm going to call one X and one Y. Oops, you can't see it. So let me write an equation. We know that our triangle has to add up to 180, right? So here I have X plus Y plus a 90-degree angle adds up to 180. What does that mean that X and Y have to add up to? If this is true, then just these 2 angles together have to add up to
45.
No, more than they could be both 45 if you're saying each of them individually, but together, if I subtract 90, they have to add up to
Oh, 90.
90. So it could be 45 plus 45, it could be 30 plus 60, it could be all sorts of combinations. What is that called when two things add up to 90 degrees? Complementary. Okay, so that's just a property that we would have worked through and figured out, but anytime I have a right angle, my remaining two angles have to be complementary, add up to 90. Supplementary, add up to 180. Complementary, they have to add up to 90, okay, because that's what's left in my triangle. So our last one, so it says if two angles in one triangle are congruent to two angles in another triangle. So I'm going to draw two triangles. And if this angle is 40, and I have the same angle over here, okay, so there's one angle that's the same. If I have another angle, we'll say it's 60, and I have the same angle over here. If two angles in one triangle are congruent to two angles in another triangle, then the third angle must also be congruent. Does that make sense? Because whatever it needs to be, it has to add up to 180, okay? This angle would have to be the same. The reason is because the triangle has to total 180. So if the triangle has to total 180 and I have 40 and 60 and it's the same over here, that adds up to 100. That leaves me with 80 degrees. So if I know two angles are the same, I also know the third angle is the same between those two triangles. Okay, this angle would have to be 80. There's no other way around it. So if two angles are the congruent to two angles in another triangle, then the third angle is congruent too. So the triangle has to add up to 180. That has to be true. Okay. The last property, so this is kind of like stuff we probably could have discovered on our own, given a little time to explore triangles. This last one is a theorem that we need to use sometimes depending on where X is basically in our problem. And I pointed this out when we went over the homework, okay? This is called the exterior angle theorem. So the measure of an exterior angle, so an exterior angle would mean here. Okay, so here's my exterior angle. These guys, in relationship to this angle, are called the remote interior angles, which means they are not, we'll say, connected. But the word you may see in a textbook would be adjacent to the other exterior angle. Okay, so these are remote to this angle because they're not this interior angle here, which is connected by a linear pair. Okay, they're remote compared to that exterior angle. So what's true here, which we saw in our homework, is we know that this is a linear pair. Okay? We know that this is a linear pair, which means this exterior angle and this angle add up to 180. We also know that this angle and these angles add up to 180 because a triangle totals 180. So the theorem states that the exterior angle is equal to the sum, which means addition, of the remote interior angles. Now, quite honestly, we don't always have to use that. In this example, we would have to use that theorem because I don't know what this angle here is. So I can't say I can't find this angle, then use the linear pair to get here, okay? Because I don't know this angle here. I could write an expression. I could say that this is 180 minus 5x. I could write that this angle is 180 minus 5x, and that's a way around it because it's a linear pair, and I could add all of those up then. Okay, so auxiliary line, that's here. That's just saying it's the dashed line. Okay, it's just added to a diagram to help us. So what our theorem says is this exterior angle, which is 5x, must be the same measurement as these two interior angles. Because these two interior angles, triangle equals 180 with angle, let's call this angle 1, with angle 1. Okay, so I know that this has to add up to 180 with angle 1, and this is a linear pair with angle 1. So because they both have this relationship, linear pair means has to add up to 180 with angle 1. These have to add up to 180 with angle 1. Because that's true, then they must be the same amount. They must be the same measure. And so I can use that theorem to solve, subtract x, for x equals 120, or x equals 30. But many times we don't have to. So even on the examples here, I don't have to use that exterior angle theorem because I can use if I have this degree, then I can just use the linear pair. You'll see on your notes, you won't always have that degree. And so if you get stuck, go back to here, and it'll also show you another way to set this up. I wouldn't use this theorem for here. I'd say if this is 111, then this would have to be what, 69 degrees here. Okay, because it has to add up to 180. And if I know I have 69 and 60 degrees, that's going to be 129 degrees between those two. So to find angle G, I would have 51 degrees left in my triangle. Okay, so certainly don't make your life harder than it needs to be. On the homework, there might be one. It's number 3, that you actually have to use the exterior angle theorem. Many others you can kind of do a workaround. Same idea here. I could say, well, if this is 68, then this has to be 112. And then from there, I could say that all together, this has to add up to 180. So I could say that 3x plus 4x plus 5 plus 112 has to add up to 180. Or 7x plus 117 equals 180. Solving for x, so 7x equals 63. And divide by 7 and x equals 9. Then for this problem, because I knew all 3 of these had to add up to 180, it says find angle D, so I need to plug in 4x plus 5, I need to plug 9 in. Which gives me 36 plus 5, or 41 degrees for that angle. Okay, so there are workarounds. The exterior angle theorem, the other way that I could have set this up is saying this exterior angle, I don't need a apostrophe there. The exterior angle 68 is equal to the remote interior. So alternative setup would have been this. Could have said that 68 equals 3x plus 4x plus 5. Okay, but again, there's many times a workaround another way. Okay, so this theorem comes up sometimes, don't always have to use it.